Okay, for the theta join, the C denotes a condition. So the condition used in the theta join, they can be very different in different formats. Beside the cells dot bar equals to bar name condition used here, we can also define some other conditions, right? So this is about theta join. And we can also have a very special case of the theta join, which can be denoted as equi-join. We say equi-join is a special case because for the equi-join, we specify the condition C in the theta join as some equinities. In other words, we require this condition to be some equinities. And the equi-join can be defined in a very similar way as a theta join. The main difference will be about the conditions. We do not allow some other conditions to be used here. All the conditions to be included should be some equinities. And the result schema will be the same as the product, right? And they may have fewer tuples than the products. And we can represent the equi-join as R1 equi-join with some equinity condition like A equals to B. A denotes the attribute from R1, B denotes the attribute from R2, and followed by this R2, right? This equi-join is the operator between R1 and R2. We will also introduce another join in the following pages. It's called natural join. Actual natural join is also a special case of equi-join to be introduced later. And not so research has been done on joins for database systems. And the main focus and the target will be to do the joins among tables in a very efficient way. So there are so many papers on this topic in academia. And this is about equi-join, right? Equi-join is very easy to understand, and we can just define it in a similar way as theta join we showed before. And then next, let's go to another join. It's called natural join. Natural join is slightly different because for the equi-join and theta join, the schema of them, they are both the same as the product of the two relations. I mean, schema of the product, right? However, for the natural join to be introduced here, they will be very different. The given two relations R1 and R2, we can denote the natural join between them as R1 join R2. For the join here, we have no conditions, we have no subscript. It's just a join. If so, then we can say this is a natural join between two relations. So R1 is a relation with A1 to AN as the attribute. R2 is a relation with B1 to BM as the attribute. Then how about the output? We know the output will still be a relation, right? Then how about its attributes? It will be different from the theta join and equi-join. Before we say that for the theta join and equi-join, the attributes of the output will be A1 to AN combined with B1 to BM, right? However, for the natural join, we can represent the attributes of the output relation like S as C1 to Cp. What are them? Actually, C1 to Cp equals to what? Equals to A1 to AN unions B1 to Bm. You can see the difference. Before the theta join and equi-join we showed in the previous pages, the output relation will be A1 to AN combined with B1 to Bm, right? The total number of attributes will be n plus m, right? However, for the natural join here, the number of attributes will be p, right? P equals to what? Will be equal to the size of A1 to AN unions B1 to Bm. If we have some common attributes between A1 to AN, B1 to Bm, then the number of attributes in the output relation, the P, will be smaller than n plus m, right? So this is about schema. And how about the data tuples or pairs in the output? So in the operation, we will combine all the pairs of tuples from R1 to R2, which agree on some join attributes. What do I mean by the join attributes? Because we didn't specify any attributes in the join, this operation here, right? Actually, this operation will find the join attributes automatically based on the important relation schemas. And formally, we can define the join attributes between R1 and R2 as A1 to AN cap B1 to Bm. So this operation can find the common attributes between these two relations automatically, and also do the joins based on these common attributes or the join attributes. So you can see the difference, right? Then you may also wonder, how can we represent this kind of natural join with some basic operations we defined before? Will it still be the same as the an theta join and equi-join we showed before? Actually, it will be slightly different. Let me show you how to define as a natural join based on the basic operations we showed before. And we can provide the formal representation here. So formally, let's assume we have two relations. We have R1. R1 has attributes like A1 to AN, right? And we have another relation R2. It has attributes B1 to Bm. And the question will be, what is and how to define R1. Let me copy the join operation we get from the web, and we can denote it as R1 natural join R2, right? So we know the natural join definition will be different from the theta join we showed before, right? So for the theta join we mentioned, right, it combines two tables together by using the product first and then uses selection, right? And for the natural join, it will be slightly different, right? And let's assume we can represent the output as a S, right? And let's assume we get the attributes. Let's assume we can represent the output as S relation. S has the C1 to CP, right? And we also get the join attributes as like we can represent it as like a D1 DQ, right? It equals to what? It equals to A1 to AN cap, right? It equals to A1 to AN cap B1 to Bm, right? Let me change this format. It's 40, right? Okay, then how can we define this R1 and R2, the natural join between them? First one, it is still based on the product, right? You can still calculate the R1 times R2 first. Then outside it, we still have the select, right? We have select. Let me get the sigma here. We still have a select. What will be the select we have? We will have this. The condition for the selection will be what? The condition for the selection will be we have this R1 dot D1, right, equals to R2 dot D1, right? And let me get this one as a base case. Right. And R1 dot D2 equals to R2 dot D2, and blah blah blah, right? And R1 dot DQ equals to R2 dot DQ, right? So the D1 to DQ denotes the shared joint attributes between these two input relations. Is it enough? The answer is no, right? Because for the C1 to CP in the output relation, they don't equal to the, they don't equal to the combination of A1 to AM and B1 to BM, right? We mentioned the C1 to CP, they equals to what? They equals to A1 to AN unions B1 to BM, right? In other words, the output schema will be slightly smaller than the combination of these two input relations, right? Therefore, for this definition of natural join beside the selection, we need to first do the projection here. We can copy the pi here. We denote the pi as the projection, right? We further do the projection to select a bunch of attributes. What are the attributes we're going to select? Yeah, the C1 to CP, right? Therefore, we do further a projection here, C1 to CP as to get these attributes, and we can just represent them as a subscript. I hope you can follow me, right? So for the natural join between R1 and R2, inside it we still calculate the product between two relations. It is necessary. And we also do this selection. And the selection is based on the join attributes. We want to ensure that the data tuples on the shared attributes are equal to each other. And besides this, we will do further projection to get the attributes C1 to CP. Therefore, the output relation, the schema will be S with C1 to CP. And for data tuples, they will agree on the join attributes by default, right? The value should be the same between the same attributes shared by this R1 and R2. And let's assume we have a very special case. If given two relations R1 and R2, and all the attributes inside between them, they are all different. They are all different. If so, if all the attributes between them they are different, then this D1 to DQ will equals to what? Because all the attributes are different, and the intersection between them will be a empty set, right? If all the attributes are different, the union between them will equals to what? C1 to CP equals to A1 to AN and B1 to BM, right? Therefore, if this R1 and R2 they share no common attributes, then the natural join between them will be equals to what? In other words, this selection has no function anymore, right? It is useless. It will be similar for the projection. The projection will project all the attributes, right? It is useless neither, right? Therefore, if R1 and R2 they share no common attributes, then the natural join between them equals to R1 times R2, right? But this is a very special case. And normally, if we use a natural join between two relations, we assume they can share some common attributes, then this join will be meaningful, right? Otherwise, we just calculate the product. It is meaningless. Okay, this is a natural join, and I hope you can follow me.